sin square x equal to 1 by 4. Second, cos square x equal to 1 by 4. 3 tan square x equal to 1, where zero is less than or equal to x, less than or equal to 360 degree or 2 pi. Well, this is a typical example of allied angles. Let us take out this sin square x equal to 1 by 4. From here we have sin x equal to plus minus 1 by 2. So, from here further sin x equal to plus 1 by 2 and sin x equal to minus 1 by 2. Sin x is positive in first and second quadrants, whereas sin of x is negative in third and fourth quadrants. Well, if it is positive in the first and second quadrant, so value of x will lie either in first or in second. Similarly, sin x is negative in third and fourth quadrants. So, therefore, angle x here will lie in third and fourth quadrant. So, if we observe the value of sin x, which is 1 by 2 in the first quadrant, orally we know it is 30 degree. But to find the value in second and third and fourth quadrant, we make use of this chart. And we shall see to it, this chart will be used in other problems also. This is x, x dash, y dash and origin. If you have to find out value in the first quadrant, so this is 0 to 90. If you have to find out value in the second quadrant, it is 180 degree minus theta. In third quadrant, it is 180 degree plus theta, the 360 degree minus theta. Well, here theta stands for the value of the trigonometric function or in the first quadrant. Now, for instance, if sin x is 1 by 2, in first quadrant we have x equal to 30 degree. Now, to find value in the second quadrant, so we make use of 180 degree minus 30 degree, the value in the first quadrant 30 degree, this. Likewise, for third and fourth quadrant, x is third quadrant we have 180 degrees plus theta, that is 30 degree, the value in the first quadrant. and 360 degree minus 30 degrees in the fourth quadrant. And if we simplify, it comes out to be x equal to 30 degree, 150 degrees, here x equal to 210 degrees, and here it is 330 degrees. So, finally, for sin square x equals to 1 by 4, we have x equal to 30 degrees, 150 degrees, 210 degrees and 330 degrees. Well, if we take either of the values 30 degree or 150 degree, so sin of 30 degree is 1 by 2, sin of 150 degree is also 1 by 2. If we take 210 or 330 degree, the value of x, sin of 210 will be minus 1 by 2 and sin of 330 degree will be minus 1 by 2. So, thus we have these 4 values which satisfy this question. If we continue with others, 2 examples, see cos square x equal to 1 by 4. So, from here we have cos x equal to plus 1 by 2 and cos of x equal to minus 1 by 2. Here again we take this chart. This is basically this chart, you will take it as the horoscope of trigonometry, and this will be used in many chapters in class 11 and 12. So, here in this case cos x positive in first and fourth, cos x is negative in second and third quadrants. So, therefore, x will be 60 degree because cos 60 degree is 1 by 2. In fourth quadrant is 360 minus 60, and here in this case x equal to in second quadrant 180 degree plus 60 degree and 180 degree plus 60 degree. Here is for third quadrant, here it is for second quadrant as this. So, therefore, x equal to 120 degree and third quadrant is 240 degree. Here x equal to 60 degree and 300 degrees. So, thus for cos square x equal to 1 by 4, we have x equal to 60 degrees, 300 degrees, 120 degrees and 240 degrees. Similarly, we can solve the third problem. 3 tan square x equal to 1 or tan square x equal to 1 by 3 or tan of x to plus minus 1 by root 3. So, here in this case tan x equal to plus 1 by root 3, this is positive in first and third quadrant. So, the tan x is negative in second and fourth. So, therefore, x is in first quadrant it is 30 degree and in third quadrant it is 180 degree plus 30 degree, that is x equal to 30 degree and 210. Here x equal to 180 degree minus theta in the second quadrant and fourth quadrant we have 360 degree minus theta, that is x equal to 180 minus 30 degree and 360 degree minus 30 degree. Finally, x equal to 150 degrees and 330 degrees. So, finally, for tan square equal to 1 by 3, we have x equal to 30 degree, 210, 150 degree and 330 degree. Let us solve some other typical problems in allied angles. For instance, we have prove that cos of 24 degrees plus cos of 55 degrees plus cos of 125 degrees plus cos of 204 degrees plus cos of 300 degrees equal to 1 by 2. Well, we keep our eye on 24 degrees and 204 degrees. 204 degree can be written as cos of 180 plus 24. Keeping in view this 24 degrees. Likewise, if you keep your an eye on 55, so this can be written as cos of 180 minus 55. So, this is equal to minus cos of 55 degrees and this is equal to minus cos of 24 degrees. Making use of the rule here, 180 degree is an even multiple of 90 degrees plus theta. That means we have made use of this result cos of 180 degree plus theta, which is equal to minus cos of theta. In third quadrant, 180 degree plus theta is in the third quadrant. And the other result we made use 180 plus minus theta here. So, this is again minus cos theta, that cos theta is negative in second and third quadrant. Here it is. So, finally, we have from this result, if you take the left hand side, this is cos of 24 degrees plus cos of 55 degrees, and instead of cos of 125 degrees we shall put down as cos of 55 plus cos of degrees plus cos of 300. This can be 360 minus 60. Now, this cos 24 degree gets cancelled with this, 55 gets cancelled with this, and you are left with cos of 60 degree for this, which is equal to 1 by 2 and right hand side. I hope this example is clear to you. We take another example. Find the value of x from cosec of 90 degrees plus theta plus x cos of theta cot of 90 degrees plus theta equal to sine of 90 degree plus theta. Now, here we shall make use of the first rule. Angle theta is being added to odd multiple of 90 degree. So, R, this cosec will change into this co-ratio, which is secant of theta. 90 degree plus theta lies in the second quadrant. You can check. This is starting from here 90 plus theta. Here we have the problem of solving this equation, where we have to find the value of x. Cosec of 90 degree plus theta is secant theta, because 90 degree is an odd multiple of 90 degree. So, this trigonometric ratio will change into its co-ratio, which is secant theta, and lies in second quadrant. Here this is 90 plus theta, 90 second quadrant. In second quadrant we have cosec positive plus x cos of theta within bracket. Now, cot of 90 degree, again 90 degree is an odd multiple of 90 degree, cot will change into 10. And next we have to see that whether it is positive here or negative. 90 degree plus theta, I explained it lies in the second quadrant, and in second quadrant cot is negative, equal to cos of theta, it is positive because sine is positive in the second quadrant. Or I can write down this as 1 by cos theta minus x cos of theta sin theta upon cos theta equal to cos of theta. this cos theta will cancel out, and by transposition we have 1 by cos theta minus cos of theta. This, bring this to left side, x sine of theta, or 1 minus cos square theta upon cos of theta. This is cos equal to x sine of theta, or sine square theta. This is a formula used in 10th class, cos of theta into 1 by sine of theta is x. This sine theta and this cancels, and finally x equal to tan theta. Again, we have another problem. Okay, this is a cyclic quadrilateral. A quadrilateral inscribed in a circle. This is A, B, C and D. So, cyclic quadrilateral. Opposite angles in a cyclic quadrilateral are supplementary. This is a relation in cyclic quadrilateral. So, we need to prove that cos of A, cos of B plus cos of C plus cos of D equal to 0. So, take the left hand side, cos of A plus cos of B. Replace this angle C by cos of 180 degree minus A, and replace this angle by angle D equal to 180 degree minus B, C equal to 180 degree minus A, plus cos of 180 degree minus B. So, further this is cos A, cos B minus cos of A in second quadrant negative minus cos of B, it is also second quadrant. All these gets cancelled, the result is 0. It's a right hand side. Now, at this stage, after having learnt the basic concepts of allied angles, now we are going to discuss the basic trigonometric formulas. These formulas form the backbone of all the subjects. It may be trigonometry itself or calculus, whether it is differential calculus or integral calculus. It forms the basic formulas in these topics. So, without profile, put down these formulas. Sine of A plus B. So, this is sine of the first angle A, cos of the second angle B plus cos of the first angle into sine of the second angle. Then we have cos of A plus B. So, this is cos of the first angle, cos of the second angle minus sine of first angle and sine of second angle. Then we have tan of A plus B. So, the tan of the first angle plus tan of the second angle upon 1 minus tan of first angle tan of second angle. Now, this is sometimes called as compound angles also. Instead of plus sign, if we have a minus b, so same trigonometric ratios will follow, excepting sine of a first angle, cos of b second angle. You observe that this part is same as this, minus cos of the first angle, sine of the second angle. Likewise, cos of a minus b. Now, the difference in this case would be, if you have plus here, in between you will have minus, but if it is minus here, in between you have cos of the first angle, cos of the second angle, plus sine of the first angle, sine of the second angle. Then we have tan of a minus b. So, that is tan of the first angle minus tan of the second angle over 1 plus tan of first angle into tan of second angle. Then plus angle A, that means A is replaced by 45 and B is replaced by A. So, we have tan of the first angle plus tan of the second angle upon 1 minus tan of the first angle, tan of the second angle. So, we know that tan of 45 degree is 1. So, we replace tan 45 by 1. So, the tan of 45 degrees plus A is 1 plus tan of A over 1 minus tan of A. Similarly, in this case, tan of replace A by 45 degrees minus A, B by this angle. So, on the right hand side this will be tan of 45 degrees minus tan of A upon 1 plus tan of 45 degrees into tan of A. So, tan 45 degrees 1 minus tan of A over 1 plus tan of A. Now, this formula tan of A plus B is tan A plus tan B or 1 minus, this can otherwise be proved. Tan of A plus B as sine of A plus B upon cos of A plus B. So, this is equal to, write down formula for sine A plus B, sine A cos B plus cos of A sine of B upon cos of A cos of B minus sine of A sine of B. Dividing numerator and denominator by cos of A into cos of B. If we divide cos A by cos B, this becomes sine of A cos of B upon cos of A cos of B plus cos of A sin of B upon cos of A cos of B whole divided by cos of A cos of B upon cos of A cos of B minus sin of A sin of B upon cos of A and cos of B. If you cancel out cos B here, you are left with tan of A plus if you cancel cos A here plus tan of B upon cos A cancels with this, cos B cancels, you are left with 1 minus tan of A tan of B. See here, it is sin A upon cos A is tan, sin B cos B. This is an example I have given you for proving tan A plus B. Likewise, you can prove tan A minus B and cot of A plus B. So, this is cot of A, cot of B minus 1 upon cot of B plus cot of A. This is an exercise I am leaving for you. You can prove this result by writing cot A plus B as cos A plus B over sin A plus B and cot A minus B. So, this is equal to cot A cot of B plus 1 upon cot of B minus cot of A. Next, we prove that number 1 sin A plus B multiplied by sin of A minus B. So, this is sin square A minus sin square B, and second result is cos A plus B multiplied by cos of A minus B is cos square A minus sin square B. In second formula, generally students commit mistake in writing as cos square A minus cos square B, but it is cos square A minus sin square B. Well, let me prove the second. So, left hand side we take cos of A cos of B minus sin of A and sin of B into cos A cos of B plus sin of A sin of B. Now, make use of the algebraic formula. Algebraic formula, that is A minus B, A plus B as A square minus B square. Use this here. Because this first term is same as this, second term same as this, there is a difference of sign, minus here plus here. So, this will be equal to cos square A cos square B minus sin square A and sin square B. Well, my requirement is cos square A on the right hand side. Yeah. So, keep cos square A as it is. So, 1 minus sin square B. I have written for cos square B. Likewise, minus sin square B I require. One minus cos square A. When you open it, simplify, you will get the result as cos square A minus sin square B, and it's the right hand side. Well, this I just given a hint for proving it. The first result you can prove yourself. Then we have sum and product formulas. This is sin A plus B plus sin of A minus B, and sin of A plus B minus sin of A minus B. If we compare these two results, this and this, sin sum, sin difference, in between you have plus, and here in between you have minus. If it is plus, on the right side you will have twice sin A first, cos of B, and if you have minus in between, you have twice cos first and sin later. Then we have next is, this is number 1, this is number 2, and number 3 is cos of A plus B plus cos of A minus B. This is twice cos of A, cos of B. You have plus sign in between cos and cos. If it is fourth formula, it is cos of A plus B minus cos of A minus B. Then it is minus 2 sin of A, sin of B. Or otherwise, if you want to write down, this can be written as cos of A minus B पहले आ जाएगा और minus cos of A plus B. So, this is twice sin of A and sin of B. Well, in these first 4 formulas, we change into the product form. So, let A plus B stands for angle C and A minus B stands for D. That means A plus B, this angle, by C, and A minus B by D in all the cases. So, we find the value of C and D separately, for A and B separately, adding. This cancels, 2A equals to C plus D and A equals to C plus D by 2. Plus B is C, A minus B is D. Subtracting. So, this is minus plus minus, A cancels, 2B equals to C minus D, B stands for C minus D by 2. In the first 4 formulas, we replace A plus B by C, A minus B by D, and A by C plus D by 2, and B C minus D by 2. So, these four formulas become sin C plus sin D equals to 2 sin C plus D by 2 cos of B, that is C minus D by 2. Sin C minus sin of D is 2 cos C plus D by 2 sin C minus D by 2. Cos of C plus cos of D equal to twice cos of C plus D by 2 cos of C minus D by 2, and cos of C minus cos of D as minus 2 sin of C plus D by 2 sin of C minus D by 2. Now, or this can be written otherwise, or cos C minus cos of D as 2 sin C plus D by 2 sin of D minus C by 2. This is here because sin of C minus D by 2 can be written as sin of minus common D minus C by 2, and sin of minus theta is sin of theta with minus sign. So, this minus will outcome minus sin of D minus C by 2. So, because of this minus, this sign will go and becomes to this. So, D first, then C. That's all.